All right. As a continuation of what we had yesterday, so I hope you did study that one because the only way for you to be able to understand the concept of geometric sequence and series is for you to get used to it. So this is the item which I asked you to skip yesterday, and so we're going to do this one today before we have another set of activity. Okay, pause this video and try to read the situation and give it a shot in analyzing it. However, if you have answered it already, you can check your answers and then try to compare it with the ones that we will be having right now. So you could try to check if you got the correct answer or not. So pause this video first. All right. So assuming that you already have read the situation and do the necessary initial steps. So if you try to look at it, the situation talks about students shading a circle each time. Okay. So first up, we are talking about the area of the circle being shaded. So the formula for the area of a circle is actually pi r squared. Now remember, you are being told here to determine the area in terms of pi. So which means we have to keep the area with the pi or without simplifying pi. So we don't have to multiply the value of the pi that with r squared. So we have to keep it as pi. That is what in terms of pi means. Okay? So in the first circle, the first student actually shaded um, half of it. Okay? So we can think of this, the area shaded, this one, will just simply be half pi 4 squared. 4 being the radius. Okay? So this would give us 8 pi. So that is the area shaded in the first circle. Now what happens is this circle will be given to the second student, and then the second student will have to uh, shade a portion of it. In other words, the area shaded, the total area, this area shaded in the second circle by the second student, or in the second circle, let's have it second circle. The area shaded seems to be the one or the work of student one. Let me call it S1 plus S2. Okay. So this is now the total area shaded by S1, student 1, and student 2. And as we proceed to the next circle, this one, all right, seems to be the area shaded, okay, let me just put it here, by student 1, student 2, and student 3. In other words, the area shaded, the total area shaded, serves as the sum. So since it's the sum, therefore, this is series, not sequence. Okay? So this is now a series. All right? Now, next. What kind of series? Is it geometric or is it arithmetic? So if you try to observe the amount of area shaded by the first student going to the second, going to the third is not the same. So for it to be arithmetic, the increase or the decrease must be uniform or must be constant. But because it's not constant, therefore it must not be arithmetic. Obviously, there's no other sequence that we've discussed. So we could predict this to be geometric. Okay? So our prediction is that this must be a geometric series. All right? So right now we are pretty sure that it's geometric series. Okay? And we can now make use of the formula for the geometric series. But before we use the formula, we need first to find the common ratio. So we need to know what the common ratio for this is. All right. So um, if we try to look at this, for instance, if we continue the areas, let's try to have this one first. This one. The total area shaded here, if you try to look at it, so it's already more than half, which in this case is already like 75% or 3/4. So the total area shaded is already 3/4 of pi r squared, all right, which gives us a total of 12 pi. Now take note, okay, that this is not a term, but rather this is equal to S sub 2, meaning it's equal to the total sum of the two students already. So not a term, not u sub 2, okay, not equal to u sub 2, but it's equal to S sub 2, meaning geometric series, the sum. Okay, so that's very, very important. All right. Now, again, we need to find first the the ratio, the common ratio. Why do we need to do that? Now, let's try to go back to the formula for the geometric series. So the geometric series formula is this. By the way, this one is finite because we only have five circles, so we know how many terms in the sequence we're gonna add. So the formula is S sub n for the finite geometric series is equal to, we have u sub 1 first term times r raised to the power of n minus 1. Take note, the minus 1 is for the entire r sub n, r power of n rather, over r minus 1. Okay. Now, what is the question asking us to do? The question is asking us the total area shaded by the five students. That means we are asked to find the total area for this. Okay. So it's the same as finding the total sum of the area shaded by the five students. That would be S sub 5. Okay, this is now equal to, all right. Uh, if you try to look at this, we can look at it as if the first term, or the first one, this one, is actually our first term. The first area shaded, that the total area shaded by the first student is actually our first term in a sense, because that is the first data that we have. So we can make use of it as our u sub 1. So we can say 8 pi times. Now the problem is we don't have the ratio, common ratio. That is why I said we need to find the common ratio first. So this is minus 1 over minus 1 here. So we need to find what r is first in order for us to find the total area shaded by the five students. So how can we find the total ratio here? You might be able to analyze from the figure that each time the area shaded is like half, it's only half. For example, the total area shaded here is one half. Here, the total area shaded is one half of the previous. Here, it's one half of the previous, and so on and so forth. So you can just go ahead and use half as the common ratio. But if you want, sorry, if you want to really prove, because sometimes whatever we see might not be the case. So if you wanted to prove it, we can actually make use of these two data that we have. Okay? How? Now take note, 12 pi is your S sub 2. Remember, it's your S sub 2, the sum of the total area of the two students, shaded by the two students. And we have U sub 1 as as 8 pi. Okay? So we can actually somehow establish an equation using the formula for the finite geometric series. So we can say 12 pi, which is your S sub 2, is equal to 8 pi, your U sub 1, times R power of 2, because N is 2. That's two students. Okay? minus 1 over r minus 1. All right. Now, in this case, before you make use of any GDC, let's simplify this first, especially if the points in the IB exam is quite high. The examiner would want to see you simplifying this. So basically, we can factor this one out. So recall your factoring methods. Your factorization. 12 pi is equal to 8 pi. This is a square a difference of two squares. So this is equal to r minus 1, r plus 1, all right, over 2 over r minus 1. By which we could already cancel this out, okay, leaving us with 12 pi equal to 8 pi times r plus 1. Okay. Now, you could go ahead at dividing both sides by 8 pi so that only the unknown variable will be left on one side. Okay. And then from here onwards, that's when you could already make use of GDC. So you have r plus 1 equal to 12 pi over 8 pi. From here, GDC, since we are only expecting for one answer because it's only r raised to the power of 1, so you can make use of the numeric solver instead. So GDC, give yourself some time to solve this one. And if you do use GDC, r returns to be half. So this is our common ratio. So once we have the r already, then we can proceed at solving for the question in A. So r is half, power of 5, and this is also half. Okay, take note it's power of 5 because it's 5 students. Okay, so this is power of 5 because we have 5 students. So we are just putting it in. So go ahead, use your calculator. So S of 5 is equal to, if you use your calculator here, it actually will give you an answer of 48.7 centimeters squared. Now, since the question is asking you to write it in terms of pi, this one, we can expect this as this one is just the same as the value times pi. So it's like we are multiplying pi to whatever value is. So for us to get back pi, so we can just simply divide this 48.7 divide by pi. Okay, so that we can keep pi. So this will give us 15.5. Okay, and then we have pi. Okay, so the purpose of dividing it by pi is for us to write it in terms of pi. So it's like we are removing pi from 48.7 because we wanted to keep pi as is. We don't want to multiply the value of pi to the coefficient, the numerical part. Okay, so it's 15.5 pi, or you can write this as 31 over 2 pi. And that is the total area shaded by 5 students. Next, letter B. So find the number of students required to shade 99% of the circle. Again, you can pause this video and then give it some try. Now, assuming you have done or you have already paused the video a while ago. So, sorry, 99% of the circle, that means 0.99 of pi 4 squared. Okay? And we wanted to know how many students. The number of students referred to the n in the series. And this one is the sum. So that's why we have S sub n is equal to this. And we're looking for n. All right? So this is now equal to, let's try to write the formula first. S sub n is equal to u sub 1 times r power of n minus 1 over r minus 1. We know already u sub 1 and we also know r, so we can just go ahead 0.99 times 16 pi equal to u sub 1 is 8 pi times half of n minus 1. And then you have half minus 1. Okay? Again, if the points in the IB exam is quite high, we need to solve this first. All right? So we can simplify the one below. Don't do it manually. Please use your calculator. So 0.99 times 16 pi. So we can simplify this part here using your calculator. So this now becomes equals 8 pi half power of n minus 1 negative 1 half. All right. Now to simplify further, we can multiply both sides by the denominator negative 1 half. So this gives us, so we distribute. So the left side now becomes 8 pi times half of n minus 1. Okay? While the right, that's the right side rather. The left side, we can multiply, sorry, we can multiply negative 1 half with 16. So this gives us negative 0.99 times 8 pi. Okay? So 16 divided by 2 is 8, and then it's negative, so this becomes negative as well. So further, we can divide both sides by 8 pi. Again, we do this if the points are high, no, in the IB exam. I mean, the points of this item, because that means the examiner would want to see a portion of your solution. Negative 0.99 equal to half power n minus 1. This time, GDC, go ahead. Since we're only looking for one possible value of n, then you can just make use of the numeric solver. So pause this video, go ahead and solve it. And if you do so, you'll get an answer of n equal to 6.64. Now, take note, we're talking about students. So we cannot have a fraction, like lesser a student, which is like lesser than 1. Or there's no such thing as 0.64 student. This doesn't exist, no? So, and if we go for 6, it will not reach 99%. So in other words, we can say to reach 99% shaded, so 7 students are required, are needed. We cannot use 6 because if it's 6, it would be less than 99%. And if it's 0.64, there's no such thing as 0.64 students. So that means it's 7 students. All right, last item. Pause this video and then try to work it out on your own. Okay, assuming that you're done, so there's already a clue that it's indefinite. Okay, that means we can make use of the infinite, no, geometric series. So we have S sub n is equal to, so we have, let's try to look at the formula again. It's u sub 1 over 1 minus r. So we have u sub 1 over 1 minus r. Now, if you try to analyze it, eventually, if we continue indefinitely, no, eventually the entire circle, because if you try to analyze it, the area of the circle is fixed. We know for a fact that the area of the circle doesn't change. It's fixed. The area of the circle is 16 pi. All right? Therefore, eventually, the entire area will be shaded. So we could already predict that the answer must be the whole circle, which in this case is 16 pi. But just to prove that it's really 16 pi, so you can make use of this formula. We have 8 pi over 1 minus 1 half. And then make use of your GDC. So S sub n is equal to 16 pi. And that means the prediction is indeed correct. Okay, and that's it. Please refer on to the worksheet I'll be giving you. So it's actually an IB type question on geometric sequence and series. Thank you so much, everyone.